Hello, this is Team24's interim presentation where we'll talk about our analysis and redesign of a coffee grinder. Coffee grinders are used to grind coffee beans. The ground coffee beans are then brewed in water to create coffee. Thanks to the enormous popularity of drinking coffee, 75,000 coffee grinders are made annually. The image on the right shows the CAD model of the vintage coffee grinder that we wish to redesign using design for manufacturing principles. This particular coffee grinder works by rotating the crank on the right side of the grinder by hand. This turns the bevel gears, which turns the burr grinder inside the cast iron cover. The burr grinder grinds the coffee beans, and the ground coffee beans get funneled into the drawer below for easy access by the consumer. This grinder works well for home use, but for food establishments that have to serve coffee made from freshly ground beans multiple times a day, this grinding process can be time consuming and inefficient. To speed up the process, we decided to replace the hand crank mechanism with a motor. These two versions of this vintage coffee grinder design can serve our two target customer groups: home coffee enthusiasts and small coffee shops and coffee serving food establishments. Our primary customers using the hand crank grinder will be pleased with the unique vintage style of the grinder, the ability to easily control portion sizes, and the personal customizability that comes with the hand crank mechanism. Our secondary customers using the motorized grinder will be pleased with unique vintage styling too, especially if they grind the coffee in front of their customers, as many boutique coffee shops do. The addition of the motor allows the coffee shops and food establishments to produce coffee grounds faster to meet the larger coffee demand. Also, while the coffee beans are being ground, the worker responsible for making the coffee can step away and attend to a different task until the coffee beans have been fully ground. The primary difference between our two product varieties is the motorization of the grinding process for mass use applications. You will now be taken on a tour of the different CAD models for each design.
We'll be using this model of a vintage coffee grinder, which features a removable drawer, and a casing or a housing that opens so you can put the coffee beans in, as well as a crank wheel that is used to grind the beans with a burr grinder. So if we look at the exploded view, we mainly just see the components, including the burr or the bevel gears, the crank wheel, spring, the burr grinder itself, the cover, as well as the funnel. And if we look at the case assembly, which is made of wood, we can see the construction using pins or dowels and parts. It's the same kind of construction for the drawer. But if we want to look at the general assembly for the family function that we're developing for, which is an automated version of this, which removes the crank wheel and the bevel gears, we instead added some new parts. So the new parts include a shorter burr grinder to accommodate the motor that was added. So the motor itself, a motor mount, which uses 256 screws, as well as these same screws that were used down here to reuse parts. And lastly, we have a longer spring so that the burr grinder can stay compressed and make sure the coffee beans are being ground up perfectly.
This is the first assembly sequence for the vintage coffee grinder. We decided to go for a Z-axis assembly for the first one. We started by assembling the sub-assembly of the case, followed by the drawer assembly. We then put on the funnel, followed by the shaft and the two cover halves. And then we added the support and gears. And lastly, we put on the turning handle. For our second assembly, we started with the funnel and shaft assembly. We then put on the support and gears on top of that. We connected the turning handle and helm. We then attached the case. And finally, we put on the drawer assembly.
Shown here is our assembly comparison chart. Sequence 2 ends up being slightly better than Sequence 1, primarily due to ease of testing, as in Sequence 2, each subsystem is separately assembled and then added to the overall assembly, which allows for much easier testing. Sequence 1 is also slightly better for ease of transferring and handling, while Sequence 2 is slightly better for ease of assembling in parallel. This is our functional analysis diagram. The primary goal of this product is to produce ground. In order to do this, it must contain beans, which requires a container to be opened, closed, and sealed. We would also like it to grind beans, which means we must provide motion and provide force. It also must dispense ground, which requires it to contain and guide the grounds. We would also like it to please senses. We would like to enhance the product through automated grinding, assuring dependability through supporting all components properly, and assuring convenience. This is our function component mapping matrix. Some parts may serve many functions. However, we've been able to split the product into separate assemblies to better improve it. This also shows products or parts for both the automated and manual coffee grinder. And this is the second part of our function component mapping matrix.
This is our bill of materials and cost estimation. The price per material is based off of what we found on the internet, as well as a $20 per hour assembly time cost for workers, and then we use the tables mentioned in the slides for handling and assembly time for manual assembly. Final cost per product was found to be $10.20 for the manual version. Now, based off of our quad chart, we realized that the funnel, shaft, large gear, case, and the drawer should be redesigned, while the helm, support, and small gear should be eliminated due to their high manufacturing cost.
Looking at the product family design, only one function really differentiates the two products, and that is the automate grinding function. Although functions like provide motion and provide force are completed by different parts for the two designs, where like a manual helm is used for the first design, versus the motor is used for the automated design, they provide the same function. This is also reflected in our common components table, where the platforms or the shared components are things like the case and the drawer, versus modules, which are different components, are different between the two. The axles and the gears are only needed in one, versus the motor is only needed in the automated component. Lastly, looking at the assembly sequence, there is one sequence up on the top, which uses delayed stratification, where we do the case and the drawer first, and then go to the split components on the top side for the original product. And then on the bottom, you see the components that are different for the automated process, with the red ones being removed and the green ones being specific to the automated grinder. And then on the bottom, you see an assembly sequence which does not use that delayed assembly process, where everything's added one by one and there's no section that is harmonized and held together. Thank you for watching our presentation.